Okay, lesson 49 has two parts, linear intercepts and transversals. We'll see if you like these or not, I'm not sure. The first one, we're to write an equation of a line that goes, of this line right here. Now, to write an equation of a line, this example will say write equation of this line. To write it, you need to remember that we write an equation of a line by putting the form y equals mx plus b. So if we know what the slope is, remember this is slope, and if we know what the y-intercept is, we can write an equation of a line. Now if we look at this one, we can't see where it is crossing the y-axis, so we don't know what b is. But we can identify a point on the line, and we can identify the slope. So if we have a point, points are always x, y. If we have a point, and if we have a slope, then we can solve it for b. So you're going to see these lines typically cross at some sort of a grid mark where the grids cross. They typically cross like this one cross, like if you had something, here's a grid. They're typically going to cross somewhere in a point somewhere. So if we look at this graph right here, we can see that it's going to give us this point right here, 1, 2, 3, 4. So it's going to give us the point 4, 0, and it looks like a point 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this point is 3, 6. So we can usually identify 2 points on the graph. Somehow. They might not exactly cross the grid line, but these are going to be somewhat estimated answers anyway. So what you want to do is form a triangle from the 2 points that you found on your grid. I'm forming a little triangle, and I'm going to figure my rise over my run. So I'm rising 6, and I'm running 1. The slope is downhill, so it's going to be negative. So we're kind of going down 6 into the right 1, or left 1, or up 6 and left 1. So it's going to be negative. It's a negative slope. You can tell reading from left to right, do you see how the line goes downhill? So we know it's a negative slope. So we have our slope, and we need to pick one of these 2 points. And this one's an easy one to pick. So we have our point, and this would be our x, y, and we have our m. And if we have all those pieces of information, we're going to have one equation with one thing we don't know, so we can solve it. So our y is right here. Points are always x, y. So our y is 0, our m is negative 6, our x is 4, and all we have to do is find b. So we get 0 equals negative 24 plus b. If we bring 24 to the other side, we're going to get b equals 24. Now we have everything that we need in order to write the equation. Remember, to do equation, you need the slope, which we have, and the y-intercept, which is b, which we now have. So you would just do y equals m. You put the x and y in. X and y stand for every point on this line, so there's an infinite number of points that are on this line, plus 24. And that's how you write an equation of a line looking at the graph. Most kids don't like that for some reason. I don't think it's that hard, but just find your slope, find a point, and put it in the equation. Okay, the next part has to do with trig. These are transversals and parallel lines. So there's lots of things we have to find, and we're going to have to use trig to find it. Okay, keep in mind, when you have parallel lines, the corresponding angles are congruent. So that means if z is above the parallel line to the right of the transversal, and p is above the parallel line to the right of the transversal. So this angle is equal to this angle. And we can find z because these 153 and z form a linear pair. They both lie upon the same line. So when you add those, when you subtract, they're both going to add together to get 180. So you're going to subtract 153 from 180, and we're going to find that z is 27 degrees. If z is 27 degrees, we know that p is 27 degrees. So I'm going to take and just sketch my little triangle outside here. I'm a bad sketcher. Let me just see if I can do a better triangle for you. And we can, there we go. A little big, but there we go. Okay, that's better. So we have, this is B, this is 7, this is 27 degrees, and this is A. So we can find A and B by using our trigonometry. So remember, the sine of 27 degrees, remember, so, ka, toa. Sine equals opposite over hypotenuse. So the sine of this angle is the opposite, which is B, over the hypotenuse, which is 7. So we would just do 7, we multiply both sides by 7, sine of 27 degrees will give us B. And if we put that in our calculator, we're going to get B is approximately 3.15. And this means approximately 3.15. That's our B. And then we would use the cosine of 27 degrees. Remember, cosine is adjacent. Adjacent means the one right beside it, touching it. It would be adjacent over hypotenuse. And that would be, oops, we know our hypotenuse is 7. And that would be 7 cosine of 27 equals A. And that's approximately equal to, because we're rounding, we always say approximately, 6.23. So we solved for all the angles and all the sides of this parallel line structure cut by a transversal. Let's try one more. Here we go. Same idea, except instead of having 158 down here, we have it over here. First thing we're going to do is figure out B by subtracting 158 from 180. And we're going to get 22 degrees. You can stop the video if you want and try this using trig, because it's the same thing, and see if you can get it. Okay, so this is 22 up here. Now the difference between this is we don't have either side. We only have the hypotenuse. So that's how it was before, wasn't it? Let me just see. Yeah, it's the same problem. So we can say the sine of 22 degrees is opposite over hypotenuse, n over 90, cross multiply, and we're going to get we're going to get 90 times sine of 22 equals n, and that's going to come out to be approximately 33.3. That's the side n. And to figure out, we would do cosine to figure out m, 22 degrees, would equal adjacent, which is right beside m over 90. So we get 90 cosine of 22 degrees, and that was going to come out to be 83. This is approximately 83.7 is going to equal m. Now you couldn't do tangent, because tangent of 22 degrees, you could do it once you found one of these sides. It would be opposite over adjacent, and we have two unknowns, so we can't do that one. So that's it for the lessons for this week. This is for lesson 49.